So during the development of our initial model, we faced several challenges that negatively affected our F1 score. These issues ranged from dealing with noisy data to selecting the most relevant features and tuning model parameters. To boost the performance in our updated model, we took the following steps. So we started by cleaning the data set thoroughly, which involved handling missing values and properly addressing outliers. Next, we applied normalization techniques and used appropriate encoding for categorical variables. We also engineered new features based on domain insights, allowing the model to capture more detailed patterns in the data. After testing several algorithms, we selected the classifier that showed the most promise during our initial trials. We then conducted an intensive hyperparameter search using methods like grid search and random search to optimize the model settings specifically for the F1 score. To tackle class imbalance, we adjusted class weights and applied resampling techniques to ensure the model was not biased toward the majority class. We continuously compare different versions of the model by monitoring performance metrics on our validation set. And this iterative process allowed us to refine the final version code until we observe a significant improvement compared to the initial one. And now I will explain how we assessed and improved the fit of our classifier. To ensure that our performance gains were not just due to a favorable split of the data, we implemented k-fold cross-validation. This approach provided a more reliable estimate of the model's ability to generalize to new dataset. And then we monitored learning curves to see how the model's performance changed as we increased the size of the training data. This helped us identify whether the model was overfitting or underfitting. Additionally, we used diagnostic tools such as confusion matrix and the learning curve to pinpoint where misclassifications were happening, which guided further improvement. And to prevent overfitting, we incorporated regularization techniques by adding a penalty for model complexity. We ensured that our classifier did not become too specialized to the training data and maintained its predictive power on unseen data. Each time we adjusted a parameter or engineered a new feature, we reassessed the model fit using the method mentioned above. This continuous feedback loop helps us strike the right balance between bias and variance. So, in conclusion, first, we improved performance through detailed data preprocessing, effective feature engineering, and through hyperparameter tuning. Then we carefully assess the model fit using cross-validation, learning curves, and diagnostic tests while applying regularization to reduce overfitting. These efforts result in a classifier that achieved a significantly better F1 score and showed robust performance on our validation set. Thanks for your listening.